Hi guys, so we're supposed to write another equation for this circuit. Now, do not be alarmed. This is saying ground. All of them are ground. So which means you can literally connect all of this with the line and every single voltage at this point is zero. It's just like a normal circuit. Don't be alarmed. So now the first thing you want to do is I'm going to use KCL. KCL is basically how you write another equations. So KCL basically says that the sum of currents going to a particular node is the sum of currents that are equal is equal to the sum of currents leaving that same node. I'm going to write in all my current I with the formula V higher minus V lower all over the resistor that the current is passing through at that moment. The first thing you want to do is you want to identify the nodes. Now in this case, you may pretend to say this is a node, this is a node, this is a node, and this is a node. That's what I used to do. But yes, sure, this is a node. But you see, these two nodes are connected by just a wire, which means they're basically the same node. There's no difference between them. So this entire thing here is V1. Yes, same thing goes for this one as well. They are not different distinctions because there's no element between them. It's just a wire. So at node V1, you have to pick a current direction and stick with the current direction. So now I want this current to enter into this node. So now I know that the current entering this node V1 is 3 milliamps. At this point, 6 milliamps will exist and also a current will exist at this point as well. So the current going in is 3 milliamps. I'm just going to write it as 0.003. That's the current coming in equals to the current going out 0.006, which is 6 milliamps plus. For this particular one, the current has to be written with this formula. It's going to be V higher, that is V1, that's higher voltage, then voltage drops across the resistor, and at this point, voltage is 0, so V1 over 2000 ohms. To simplify this, I'll simply multiply through with 2000. At this point, it becomes 6 equals to 12 plus V1. V1 is simply equals to minus 6 volts. We have simply gotten V1. Now for the second equation at node 2, that's at node V2, you're simply going to have that the current coming in is 6 milliamps and current exits at this position and at this position. So 6 milliamps at 0.006 is equals to, at this point, the current here will be V2 minus V0 over 5000 ohms plus the same for this one, V2 over 10,000 ohms. Multiply through with 10,000 and you're going to get your answer 60 equals to 2V2 plus V2. Simplify this is simply going to be 60 equals to 3V2. V2 is equals to 24. So you actually gotten your final answers V1 and V2. It asks for the nodal equation. This is the nodal equation, but they are very easily simplified. Thank you for listening.